Welcome back to Edexcel Science Channel, and now we are at question 14 from 2026 June Edexcel IAL Physics Unit 1. So question number 14 is saying, a vertical lift over a river can be raised to different heights so that boats can pass underneath. Okay, the diagrams show the bridge before and after being raised. Each end of the bridge is attached to two counterweights by a cable and a pulley. So, okay, so these are the cables, right? Each end has two counterweights, and each counterweight is added to is connected to a pulley. As the bridge is raised, motors transfer energy to the bridge. Energy from the counterweights is also transferred to the bridge. Okay, this is very interesting. The bridge moves up 8.5 meters and the four counterweights move down 8.5 meters. Okay. Calculate the minimum energy needed by the motors, okay, to move the bridge up 8.5 meters. All right. They have given us the mass of the bridge and the mass of the counterweights. All right. So this is a classic conservation of energy question. In such questions, it can be a little bit confusing to how to approach this type of question. And the most easy way is that you just have to figure out what is the energy in and what is the energy out. Okay, where is the energy coming from and where is it being spent? Because how we have come to this is the law of conservation of energy says that energy cannot be created or destroyed, but it can be transferred from one form to another. Meaning that however you have gotten the energy and however you have spent it, it must be equal. If you can find out the mathematical expression for this equation, you can find out whatever the question is asking you about. So in this case, right, in this case, let me write it down. So in this case, the energy in must be equals to the energy out. Now, the whole question can be done just by reading these two lines because these two lines is literally telling you how to do the question. The way you are getting the energy to lift up is from the energy of the motors and the energy of the counterweight, and you are using it to lift up, right? Now they're asking you what is the minimum energy by the motors, so you have to find out this one. So energy used by the motors must be energy used in the lift subtract and we have to subtract the energy of the counterweight. Now both of these have a gravitational potential energy. The bridge, right? Actually, instead of calling it lift, let's call it bridge. Right? That is, I guess, better. Okay. So so both of the bridge and the counterweight has a gravitational potential energy. So I can just say that mass of the bridge times the gravitational constant times the change in height minus mass of counterweight g and the change in height. So mass of the bridge is 421,234 times 9.81 times 8.5 minus. Okay, now another thing that we have to keep in mind is there is four counterweights, right? So each counterweight is has a weight of 93,000 kilograms. So 93,000 times 9.81 times 8.5, but you have to multiply it with 4 to consider all 4 of them. So this should give you about 4 times 10 to the power 6 joules of energy. So at the end, if you can figure this one out, where is the energy coming from and how you are spending it, then any question regarding the conservation of energy should be easy for you. Okay. Question number B. The bridge is sometimes raised to its maximum height and it requires a total energy of 15 megajoules from the motors. Okay. Calculate the useful output. Okay, so this is the total energy. It's not the useful. We have to find out the useful power. Okay. Now, we know they have given us the efficiency of motors. So clearly, we have to use the formula for efficiency. But I need to find out the total input power. If I have to use the formula for efficiency, then I have to find out the total power input. So power input is energy over time. So 15 times 10 to the power 6 to convert it to joules, and the total time taken is 190 seconds. Okay. That should give us 78,900 watt. Now, the formula for efficiency is useful power output divided by total power input times 100. But I don't think, actually, we don't have to use the 100 over here because they haven't given us in percentage. If they gave us 36%, then I would have used 100. So if I use this, then the power input, sorry, the power output should be efficiency times the total power input. Okay. So our efficiency is 0.36 and the total power that we have used is 78900 watts. So 28,404 watts. That is our useful power output. Question number C. The bridge could have been built using counterweights with a total mass equal to the mass of the bridge. So the mass of counterweight is equals to the mass of the bridge. Okay. Explain how using these counterweights would affect the energy input to the motors as the bridge is raised. Okay. This is a fairly easy question. Since in this instance, the mass of the counterweight is equal to the mass of the bridge, that means that the motors would have to do less work. So 2 marks, 2 points. I would say that all the work are now done by the counterweights. So the motors would have to do less work. That's all. See you in the next video.